Hello and a good day, Doctor. My name is Bunjun Phai with the matrix number AE1900091 from Team Hiden Intelligence of Section 1. In this video, my teammates and I will be presenting our group project for power system analysis. Well, I shall begin with the introduction then. Electrical power flows from the generating stations to the loads through many different branches of the network in the power system. The flow of active power and reactive power are known as the power flow or load flow, if you will. So load flow analysis or power flow analysis is a very important tool used by engineers around the world to determine the steady-state operation of an electrical power system. The studies of power flow provide a systematic mathematical approach in deciding the various elements or variables under steady-state conditions. The power system is modeled by an electrical circuit that comprises of generators, transmission networks, and distribution networks. The main crucial information that are obtained from the load flow or power flow analysis consists of magnitudes and phase angles of load bus voltages, reactive powers, and voltage phase angles of generator buses, whereas real and reactive power flows on transmission lines together with power at the reference bus. Hence, in order to solve load flow or power flow analysis problems, various numerical analysis methods have been applied over the years. Methods such as Gauss-Seidel or Newton-Raphson are the iterative methods that have been commonly used throughout the years, decades. Manual hand calculations are only suitable for the estimation of operating characteristics of a few electrical circuits. Hence, the use of computers for digital calculations have been utilized for at least around 70 years now, and there have been different ways used in calculating power or load flow. Therefore, the purpose of this project is to study and compare the use of numerical methods of Gauss-Seidel and Newton-Raphson in power or load flow analysis. Also, the case of three-machine 9-bus system will be used as the test to determine which of the two methods is the best in the studies of power system planning. Okay, so next for methodology. For this project, the test system model, which is shown here as a reference, the test system model 3-machine 9-bus system is being utilized for the power flow analysis, whereby the MATLAB software has also been utilized, invoked to assist in carrying out the simulation of the test system model. Furthermore, two numerical methods, the Gauss-Seidel method and as well as the Newton-Raphson method have been used to analyze the system. The load or power flow analysis can provide several outputs through the MATLAB simulation, such as maximum power mismatch, number of iterations, line flow, and also line losses data. To elaborate more on the power flow analysis methods, the numerical methods involving the solution of algebraic simultaneous equations forms the basis in searching for the solution of electrical power system analysis. For example, for the first method, which is the Gauss-Seidel method, this method is developed based on the Gauss method and is used for solving set of nonlinear algebraic equations. This method makes use of an initial guess for the value of voltage to acquire a calculated value of a variable. The initial guess value is then replaced by a calculated value, and the process is repeated until the iteration solution converges. Next, we have the Newton-Raphson method. This method approximates a set of nonlinear simultaneous equations to a set of linear simultaneous equations using the Taylor's series expansion, and the terms are limited to the first approximation. This iterative method is the most used for power or load flow analysis, as its convergence characteristics are comparatively better than other alternatives. And as shown in the figure below, over here, We use MATLAB. The codes are used to run MATPower to acquire the results as we call in the function in the path to run the Gauss-Seidel method and also the Newton-Raphson method. And that is all from my part. Thank you very much. I shall hand it over to my teammates next. Thank you.
A very good morning to those who are watching our video presentation today. My name is Lee Jinzhou, and now I'm going to explain with you about the parts of result and discussion. First of all, the simulation for Gauss-Seidel and Newton-Raphson method is carried out by using MATLAB. Next, the diagram shown on the screen is the one-line diagram of 3-machine and 9-bus system. Next, we proceed to the simulation result of power flow analysis for a 3-machine and 9-bus system by using Gauss-Seidel method and also the Newton-Raphson method. The table shown on the right side of the screen is the simulation result by using Newton-Raphson method, while on the left hand side of the screen is using the Gauss-Seidel. The 3-machine 9-bus system represented in next figure both consist bus 1, which acts as a slack bus, and 8 loaded buses, which are buses connected to load, and 2 generator buses, which are connected to the generator. And this should be the figure 3.4 and 3.5 in our report. And on the right hand side of the screen is the figure 3.5, which is the loaded data of power flow analysis for 3-machine 9-bus system by using Newton-Raphson method, while on the left hand side is the result by using Gauss-Seidel. Right, the 3-machine 9-bus system consists of 9 line data which contains line flow and line losses, which I represent in the next slide that I will show to you. Here is the simulation result of line flow and losses by using both Gauss-Seidel method and also the Newton-Raphson method. The line losses are compared for the both numerical methods, while the Newton-Raphson method is slightly higher in total line losses at 4.641 megawatts and 48.83 MVAR, while it is recorded that Gauss-Seidel with total line losses of 4.640 megawatts, 48.83 MVAR. From the above results simulated, there are certain conditions like tolerance use must be high enough to assure the accuracy of the system. Hence, the tolerance used in this simulation is 1 e power of -4, which is adequately represent our data in 3-machine 9-bus system. In meanwhile, the table from this slide has dissipated both iterations number of Gauss-Seidels and Newton-Raphson methods. The result shows that Gauss-Seidel method has the longest computational time and number of iteration at 2.06 seconds and 94 iteration needed to convert for the load flow analysis. On the other hand, Newton-Raphson methods only took 0.31 seconds and 3 number of iteration to converge the power flow analysis of the test system. Well, this should be the last parts that I want to mention in my parts. That's all from me. Thank you very much for your attention, and now I'll leave it to my friend. He will explain with you about the next part. Thank you.
Good morning to Dr. Haifa. My name is Daniel Gan. Okay, today I'm going to present a MATLAB 3-machine 9-bus test system. So, okay, first of all, I'm going to using a MATPower software. Okay, this is my code, and I'm going to use MATPower 7.1 versions. So I'm going to using a power flow here. Okay, there's a power flow over here. Okay. Okay. So first, I'm gonna install my Mac Power. This is a library file. I'm just gonna press this install Mac Power. Okay. Since I have just installed, so I just used temporary. Okay, so I've done. So as you can see, my path is over here. All is Mac Power path. I'm gonna set path all the way into my folder. So closed. Okay. Then I'm going to analyze this 5 meta coding. So in order to run my Gauss-Seidel and Newton-Raphson method on my 3 machine 9-bus system. Okay. Okay. First, I'm gonna do these 2 methods. Okay. So then later I'm gonna check my combination time, number of iteration, accuracy, and complexity of implementation. Okay. So this is the code for the run PF. So I'm gonna call out my function, and this is the 3 machine 9-bus system generator. This is a data sheet. I have a bus data, generator data, line data, the cost. So and next is the MP options. I'm gonna choose whether choose whether it's Gauss-Seidel or Newton-Raphson. Okay, so here's it. I'm going to use this line command. Okay, so here's the code function for MP option. I'm going to power flow algorithm and then choose Newton-Raphson or Gauss-Seidel. Okay, so here's my code. I'm going to run it for Gauss-Seidel first with a tolerance of 1 E-4. Okay. Okay, here you can see after I run my function code, I'm going to get this system summary of a 9-bus 3 generator. That is a voltage loss of line voltage loss, power loss, and reactive power loss. So here's the bus data. So it's a total of 320 megawatts, and it's a line data from bus 1 to bus 9. Okay, so this is the total loss of active power and reactive power. Okay, I'm choosing a base mega voltage ampere of 100. Okay, the number of iteration is 94 for the Gauss-Seidel method. Okay, next I'm going to use Newton-Raphson methods. Okay, so for the Newton-Raphson method, it's just the same, but only the convergence is in 3 iteration only, and then the time is 0.51 second. And for the Gauss-Seidel is 1.18 seconds, which is much more longer. Okay, so I have put my code in the appendix of my report. Okay, thank you.
Good afternoon. My name is Sushi Sen. My meeting number is AE190093. I am from Session 1 and I am also the member of Hiden Intelligenz team. Let me continue our conclusion. In conclusion, power flow analysis is a numerical analysis of the flow of electric power in an interconnected system like our project. Our project, which is 3 machine 9-bus system power flow analysis. Our system power flow analysis was carried out by MATLAB. The MATLAB with the function of the Met Power 7.1 AC power flow solution algorithm. So our test system is evaluated by Gauss Stadium method and Newton Raphson method. So we use both method to determine in order to we use both method to in order to determine and compare in terms of computational time, number of interaction, accuracy, and complexity of implementation. So last but not least, the Newton Raphson is the recommendation in the power system due to it is more efficiency, and accuracy, and then is more faster and reliable. This is all for me. Thank you.